Okay, 8th grade, this is video 2 of 8.2. I've got some steps and some tips written out for you. Anytime you're wanting to add or subtract rational expressions, you want to start by factoring completely. Okay, this tip for less work is telling you that once you've factored completely, if there's anything that you can cancel out within each fraction, you want to do it then. That way there's a lot less work for you in the end. Step 2, you're going to find the least common denominator and then rewrite each fraction so that they have those denominators. And then step 3, we will add and subtract. Here in parentheses, I have written out that anytime you can, you need to simplify the numerator completely, then factor once more. There will be times where when you add the numerators or subtract the numerators, you're going to create new factors that could actually reduce with the denominators. But in this, no, always leave denominators in factored form. Do not spend time foiling or distributing denominators. Leave them factored completely. It's only the numerators that you need to check. So we're going to start off with guided practice 2 and just properties of exponents. So there's actually no factoring involved in this first example here for video 2. So in guided practice 2a, we're looking at our two fractions and we need to find the least common denominator. One way to think of this is, what does each fraction have that's missing that the other one has? So between 5 and 10, the least common multiple is going to be 10. Remember, we said in the first video, the least common multiple of your variables are going to be the highest exponent you see. So the a cubed is larger than the a, the b squared is larger than the b. So that's going to be your least common denominator. Now, to get our fractions to have those common denominators, we need to see, well, what's missing from that least common denominator and how can I fix it? Well, the only thing that's missing down here in the first fraction is my 5 needs to become a 10. So I do that by multiplying by 2. And anytime you change the denominator by multiplication, you also have to change the numerator by that same value. So we're going to multiply the numerator and the denominator by 2, and we'll end up with 8 over 10 a cubed b squared. Same idea with the second fraction. This one, the 10's good, but we're missing some exponents here with our a and our b. So if I multiply by an a squared, that would change my a to a cubed. And if I multiply by b, that would change my b to b squared. What I do to the denominator, I have to do to the numerator. So 9a squared bc over 10a cubed b squared. All right. At that point, we have the same denominator, so then we can bring our numerator together by addition. And there's nothing we can combine. They're not like terms, so we are finished with that problem. Okay. Part B is going to work the same way, just with subtraction. So if I look at my denominators, between a 16 and a 5, the least common multiple that you come to is an 80. I have a b squared, which is bigger than b, and then I have an a cubed. Okay. So to get those denominators to be the same, I need to look and see what's missing. So from 16 to turn into 80, I need to multiply by 5. I have the b squared, but I'm missing the a cubed. So I want to multiply both the top and the bottom by 5a cubed, which gives me 15a to the 5th over 80a cubed b. The second fraction, I need to multiply 5 by 16. I have an a cubed and a b, but I'm missing another b. So I want to multiply the top and the bottom both by a 16b. Okay, that's going to give me the second fraction here of negative 128bx over 80a cubed b squared. Our denominators are now the same, so I'm going to subtract my numerators. However, again, there's no common denominators, so I'm just going to write it as a subtraction problem and box in my final answer. I'm going to go ahead and stop there. I think Augie needs a little bit of lovin's. So video 3, I will pick up with adding and subtracting when we have to do some factoring with binomials and trinomials.